I'll probably do my little bit now, and
Okay.
then I'll kick it off to you in a minute. Okay. Hello, everyone. Thank you all for being here tonight. First off, I would like to thank the Friends of Stories Library for funding this event as they fund many of our programs. I would also like to thank Joe for being here. As you may have heard him mention earlier, this is a rescheduled program that was supposed to happen earlier in the year. So we would like to thank him for joining us here tonight. We will also be having Joe back in October on October the 10th to give a talk about the upcoming eclipse happening this year and then another one happening next year in April. So stay tuned for that on our website. And with that, I'd like to kick it off. Joe.
Well, thank you very much, Amanda, and thank you for those of you who are here. And we're probably going to have a few more come in, as I've been told. Sometimes they stroll in a little late, but it doesn't really matter. I'm ready to go. This talk is going to be a PowerPoint presentation, and it is dealing with an interesting thing. People have asked me, and for over 40 years, I was a broadcast meteorologist, both on radio and television. Is it possible to tell the weather or tell the future climate using the activities that are going on in the sun, the movement of the moon, the planets even? So this talk is about that. It's called the science of, or maybe you might want to call it the pseudoscience of astrometeorology. So let's get underway here. I'm going to get my screen shared. Oh, wait a minute. I haven't even brought up my my PowerPoint thing here. Hang on for just a second. You're talking to somebody, by the way, who only recently has gone to Zoom. I used to use an ectographic projector, and I had to go screaming and kicking to learn how to use Zoom. But let's see now. There we go. Here we go. Share and slideshow from the beginning. And here we go. First of all, again, thank you so much, all of you who are patrons of the Storrs Library here in Massachusetts. I say here in Massachusetts, you're in Massachusetts. I'm in Putnam County, New York, 50 miles or so north of Midtown Manhattan. But still, it's very, very nice to speak to all of you about subjects that I love to talk about, astronomy and meteorology. So we'll begin. And what you're seeing on the screen right now is a very important book, which is published every year. This is from the Royal Astronomical Society of Canada. It's called the Observer's Handbook. And if you get a copy of this, this is for the year 2022, and I have a 2023, but I never had a chance to make up a slide for that. But if you get a copy of the Observer's Handbook for a particular year, this book will tell you everything that is going to happen above your head in the nighttime sky. The phases of the moon, sunrise and sunset, eclipses, meteor showers, times when stars, variable stars, will reach their peak in brightness or fade out. It's a wonderful conjunctions of the planets. Tonight, for example, I know that here in the New York area, we're not going to see it because it's rather cloudy, but maybe up a little further north, up into Massachusetts, after the talk, if it's clear enough, you might want to look toward the western sky for a beautiful array of the crescent moon, Venus, and the planet Mars, making a triangle in the western sky right after sunset. And how do I know that's going to happen? I looked at the Observer's Handbook. Everything about the Observer's Handbook is, for the most part, absolute. If it tells you that there's going to be an eclipse and the eclipse is going to begin, let's say on a specific date, I'll pick a date out of my head, August 2nd, not this year. I'm just using this as an example. But if this book tells you on August 2nd at 10:52 p.m. there will be an eclipse of the moon that will begin over North America, you can bet your soul that that will be correct. Everything about this book tells you what's going to happen in the sky, and astronomy is a very exacting hobby. We know where the moon is going to be at any given point. We know that the sun is going to be at a particular position based upon our orbit about our central star in our solar system. And that's great that you can rely on these predictions to be 100% or very close to 100% true. And some people say, wouldn't it be wonderful if we had a book like that for weather? Wouldn't it be wonderful if we could purchase some kind of a book, open it up, and go to a specific date and find out if it's going to rain or snow, or if it's going to be hot or cold or fair? Great for scheduling, let's say, a wedding or a graduation party or a barbecue or whatever. It'd be wonderful if there was a book out there like the Observer's Handbook for Astronomy, some kind of a book for weather. Well, guess what, folks? There are not just one, but two books, and I'm sure you've heard of these. The yellow cover is the Old Farmer's Almanac, which has been in business since the year 1792. And they have been forecasting weather in the almanac all the way back since then. And the other almanac is the Farmer's Almanac. They're not as old as the Old Farmers, but still they have been around, as you can see on the cover, since 1818. Both of these publications claim that they have 80% accuracy, 75 to 80% accuracy, and both of them claim that they use a special secret formula, which they have never allowed anybody to find out what the formula specifically is. I guess it's kind of like magicians. They don't want to share their secrets on how they did a certain trick. But these two publications publish long-range weather forecasts for every month of a specific year, and people apparently rely and hold forth to these particular publications. I would suppose that if both of these publications were wrong, terribly wrong every year, they would have been out of business long ago. But then again, they don't just publish weather information. They have all kinds of interesting stuff like astronomical information, or how to remove a corn from your big toe or something, little folksy things. In fact, you can see that each almanac has a hole in the upper left corner, and that supposedly is where you can hang the almanac on a nail in the restroom, because that's where people purportedly read this in the restroom while you were on the throne. But and to this day, they both almanacs claim they lose a lot of money by having that hole punched in to their almanac for each year. But it's a tradition, and they can't seem to not have the hole in there. So these are a couple of special publications. But again, how do they do it? How do they possibly know, or can actually say, we predict such and such? We predict that it's going to be hot on the 4th of July, or we're predicting that there's going to be a big blizzard on March 23rd. How do they do that? What methodology do they use? Do they use the phases of the moon or the movements of the moon around the Earth? Well, here is a table forecasting the weather, talking about lunar cycles. And this table, as you see here, this was published in the Old Farmer's Almanac, I think back in like the 1990s or whatever, mid 90s. And it says that this is the result of many years' actual observation and shows what kind of weather will probably follow the moon's entrance into any of its quarters being new moon, first quarter, full moon, last quarter. And if you know when let's say we had a new moon a few days ago. I haven't looked up exactly the time when new moon occurs, but let's say for convenience sake, it was occurring this past Monday, and new moon was at 8 a.m. Again, I'm just making this up. I don't have an almanac in front of me. But let's assume we had a new moon at 8 a.m. on Monday. So we check here the prediction. Let's say actually 8:15 a.m. So we check here 8 a.m. to 10 a.m. and we're into the summer season now. So what would be the weather? If this isn't this forecast changeable, that's about as precise as you could possibly get, right? So if we had a cloud-covered sky with a bit of sun, or sunshine with a few clouds passing through, I suppose that would fall into the changeable category. That's different in the wintertime. In the winter, it'd be a cold rain if the winds blow from one direction, snow if it blows from another direction. But this table was created more than 160 years ago, at least back in the 1990s, they did that, by a Dr. Herschel for the Boston Courier. and it first appeared in the Old Farmer's Almanac in 1834. But here is a way that you forecast the weather using the motions of the moon. Okay, that's good. Now, this gentleman, and boy, I tell you, when you talk about the learned gentlemen or scientists of the 19th century, here's a guy that fit the bill perfectly. His name is Elias Loomis. He was an American mathematician in the mid to late 19th century, and in 1868, he wrote a book called A Treatise on Meteorology, a big, thick book talking about all facets of the atmosphere and of meteorology. And one of the things that he spoke about was the fact that he believed that the atmosphere acted very similar to the oceans. He said, well, we know that the moon has a direct effect on the oceans by creating waves, and that we can predict the times to almost the minute of high tide and low tide. And so Professor Loomis said, so if that be the case, why can't we use the moon to forecast what may happen in our atmosphere? Because he believed that there were tides that were induced by the moon on the upper atmosphere. Now, if you ask a meteorologist today about that, they'll probably laugh in your face. They'll say, well, it's really, it doesn't really work out that way. I don't really think you can predict anything or get anything out of that. Maybe, but I want to show you a picture here. This is not of the ocean waves. These are of clouds. These are very special kind of clouds called Kelvin-Helmholtz clouds or billow clouds, and they are caused by different densities of air, or when we have an atmospheric inversion. They're also sometimes called shear gravity clouds. And I mean, look at this. This, you talk and you say, well, it can't be tides in the atmosphere, but I tell you, this certainly looks like tidal forces at work. It certainly looks like the ocean more than clouds in the atmosphere. And I'll show you something else. Watch this. This is an interesting. Now, this was taken from the summit of a mountain several thousand feet up. And what we are looking at is basically cloud cover, but it's under the observer taking the video. This is going to be a video. I'll set it in motion in a moment. So you've heard the term overcast. That's when it's very cloudy overhead. Well, could we call this an undercast since the clouds are below the observer? Take a look at this. And, I don't know about you, but this certainly looks, for all intents and purposes, like the ocean, like waves on the ocean. I don't know, maybe Professor Loomis was right to some degree. And I look at the way these clouds are just rolling along. In fact, they're almost lapping up on shore, if you can call it that, onto the side of the mountain. Pretty amazing video here. And again, rolling up along the shore of the mountains. It's pretty interesting to watch how this all works out. So it makes one wonder whether or not there are tidal forces at work thanks to the moon's motion around the Earth on our atmosphere. Here's a limerick. I don't know exactly who wrote it. When I first stumbled across it some years ago, it said anon or anonymous. And I got a chuckle out of this. But the moon and the weather may change together, but change of the moon does not change the weather. If we'd no moon at all, and that may seem strange, we'd still enjoy weather that's subject to change. Well, yeah, that's probably correct. But again, does the moon have anything to do with weather and climate? Well, I do know at least of one person. Actually, I do now, to this day, know more than one person who feels that way. You probably don't know who this guy is. And even if you lived in the New York metropolitan area, he was on television on WCBS Channel 2 in New York for one single year, 1966. This gentleman's name is Harry Geiss. And he was on CBS again for 1 year because up until 1966, on television, not just in New York, but across many parts of the country, the theme was that if you're going to have a presentation about the weather, you usually would have a woman, and usually it was an attractive looking woman, weather girls or weather ladies who would present the weather. But then in 1966, Channel 2's competitor in New York, Channel 4, got a gentleman who was a real scientist, a real meteorologist, whose name was Dr. Frank Field. Dr. Frank Field is legendary even to this day in New York. And in fact, Dr. Field, who retired many, many years ago, he just celebrated this year, God love him, his 100th birthday. But in any case, Channel 4 took out big ads and said, we have a real person to do the forecast, a real scientist, a real meteorologist, Dr. Frank Field. Well, Channel 2 said, well, if Channel 4 is going to get a meteorologist, we've got to get a meteorologist, a real meteorologist. Up until then, they had a young lady, a very nice lady who did the weather on their channel for many years, Carol Reed, and she was very, very popular. In fact, people who watched Channel 2 loved her, especially at the end. She used to finish her forecast by saying, regardless of what the weather was, he said, and have a happy. That was her theme, or her out when she finished her forecast. But now all of a sudden, Carol Reed found herself out of a job, and they brought in this guy who you're seeing on the screen, Harry Geis. Harry Geis was at the CBS affiliate in California, and they said, we need to bring this guy into New York. And they did. And they brought him in for 1966. And one of his specialties, one of Harry Geis's specialties, was doing long-range forecasts. I mean, I'm not talking about 5 or 6 days out. I'm talking about weeks and even months in advance. So when he arrived at Channel 2, the management said, all right, Harry, do your stuff. Go out there and give us one of your long-range forecasts. So Harry Geis did. On Columbus Day weekend in 1966, this is October now, he stepped before the cameras and said, I have an announcement. I am announcing that we are going to have a big snowstorm here in New York City in time for Christmas. So mark it down on your calendars, folks. This year we're going to have a white Christmas. And a lot of people probably looked at this and said, what is he, a nut? What is he, crazy? That he's so into this, that he's predicting months in advance a big snowstorm? But the interesting thing is that for all of the holidays that came after that, as I said, he made this announcement on Columbus Day. Harry Geis then on Veterans Day, another federal holiday, and he said, I just again want to remind you about Christmas. We've got a big snowstorm coming that day, and Thanksgiving. Now that's when the Christmas season began or begins, especially the Christmas shopping season. So Harry said, well, if all of you are going to be doing Christmas shopping, let me advise you to do it now, because if you try to do it around or just before Christmas, you may have a problem, because we're expecting, as we've been talking about, this big, big snowstorm. He said it enough times so people, realized what was coming, presumably or supposedly. And you know what? Harry wasn't so crazy. Take a look at this. This is the National Weather Service map depicting storms, wintertime storms. And here, right surrounding Christmas 1966, here is a snowfall chart. You can see the legend here, the light gray indicating 1 to 4 inches, the white indicating 4 to 10 inches, and in the blue, 10 to 20 inches of snow. So New York City picked up out of this storm. The snow started falling on Christmas Eve and continued until early Christmas morning and dumped about 8 or 9 inches in New York. And in places in the northern and western suburbs, over 10 inches. And look at this, in the dark shades of blue, over 20 inches of snow. Incredible. How did he know? This is it's one thing to mention this in October, not mention it again, but he mentioned it again more than several times, Harry Geis did, and people were stunned at the accuracy of his forecast. Here is the New York Times for Christmas morning, December 25th, 1966. Snow brings city white Christmas, travel snarled. It was, in the paragraph here, the first white Christmas here since 1961. So, people who said, well, we have a white Christmas every year, that's why he's saying that we're going to get a big... No, this was the first time in 5 years that we had a white Christmas. And take a look. Harry said, make sure you get your Christmas shopping in before the snow begins to fall. This picture showing the snow falling, and look at this one woman's face having to trudge through the snow to do the last minute shopping on Christmas Eve 1966. So again, how did he do that? Did he use the moon? Well, maybe he might have used the moon. He might have used the Metonic cycle. That is a special cycle, a period of 19 years or 235 lunar months, after which the new and full moons return to the same days of the year. And it was the basis of the ancient Greek calendar and is still used in calculating movable feasts such as Easter. And you think about this for a second. 19 years. So in other words, the moon is pretty much in the same position that it was 19 years ago or 19 years hence. And so the question is, if this big snowstorm that hit on Christmas 1966 happened, what happened on Christmas 19 years earlier? That would be 1947. Was there a big snowstorm on Christmas in 1947? Well, let's take a look and say, whoa, whoa. Yes, there was. In fact, up until a few years ago, this was the all-time record snowfall in New York City. A record 25 inches of snow, crippling the city and all traffic slowing down. This happened or started the day after Christmas in 1947. Still a memorable storm. A lot of people who are still alive today may remember that particular snowstorm. But the question is, did Harry Geiss use this storm to forecast the weather, the big snow 19 years later in Christmas of 1966? That's maybe a possibility. Or maybe there are other facets as well. By the way, if in 1966, I said, if you use the Metonic cycle, that means that another big Christmas snowstorm would hit in December around Christmas time in 1985. Remember that one? Anybody remember a big storm in 1985? You don't? You want to know why? It never happened. It didn't happen. So the Metonic cycle might not be the only thing. It's not a given that every 19 years the weather is going to repeat the same way that it did the previous 19 years. So maybe there are other things, other factors that go in, like perhaps the distance of the moon from the Earth. Now, the moon can come as close to the Earth as 221,000 miles. But because it moves in an elliptical orbit around the Earth, it can also be as far away as 252,000 miles. When it's far, we call that apogee. When it's near, we call it perigee. And in fact, when the moon is near and at full phase, we call that a perigean full moon, or at least we used to call it that. In the last 10 or 11 years, that term, perigean full moon, has been replaced by a new term, supermoon. The news media loves when there's a moon coinciding with perigee, and then they tell you the moon is about 14% larger and about 30% brighter than when it's at apogee or its far point in its orbit. And so the question is, does lunar distance have anything to do with the weather? Well, the man you see on your screen now, Stephen Martin Saxby. He lived in the mid to late 19th century, very much like Professor Loomis, Elias Loomis. And back in the year 1868, he wrote a letter to the newspaper. Now, Saxby was based in the United Kingdom, in the UK. And he wrote a letter to the Standard of London, one of the newspapers there, and warned them that in October of that year, there was going to be tremendous storms causing tremendous tidal flooding. Oh, it was going to be terrible. And he said the reason why was that the moon was going to be at new phase, and that at the same time the moon was going to be at its closest point to the Earth, perigee, and that the moon at the same time all this was happening was going to be passing over the equator. And that's why the basis was that this period of great storminess was going to occur and coincide with the new moon of that year. Well, his letter was published quite a few months in advance of the date mentioned. And sure enough, people started to write to the Standard of London, or even come to the newspaper office and say, where exactly is this storm going to occur that Mr. Saxby had alluded to? And so the newspaper wrote to Saxby and said, you got to tell us where this big storm is going to be. You got to tell us where to expect this major tidal flooding and all of this craziness that you were alluding to. And so he wrote another letter, which was published again in the Standard of London. And here is the quote from Professor Saxby. He wrote this in the letter, his second letter to the Standard of London, September 16th, 1869, 2 weeks before the new moon and the perigee event. And he wrote, "The warnings apply to all parts of the world. Effects may be felt more in some places than in others. It is painful to have to forebode evil, but it better thus than to merit self-reproach under circumstances which might lead to permanent regrets." What did he say? "Could I save just one life, it would be very cheaply purchased in making better known certain laws of nature." So yeah, so he's saying that there's going to be big tidal flooding and that there will be a big storm or storms, but he doesn't tell you where. He mentions that the storm could be most anywhere in all parts of the world. Now, if that is not an open-ended forecast, which cannot or could not be referred to as an inaccurate forecast, I don't know what is. But he and you know, when the moon is at new phase or at full phase, we have higher than normal tides. We call those spring tides, not in association with the spring season, but it's from a German word, "der springen," meaning the tides at those periods, new and full moon, spring up astronomically higher than normal tides around the time when the moon is new or full. And now when the moon is particularly close to the Earth, the tidal forces are higher than they normally would be at any other times of the year. That's what I'm not really, he didn't have a doctorate or a professor, but people refer to him as Professor Saxby. That's what Stephen Saxby was making allusions to, much higher than normal tides. And if there was associated with some kind of a storm, then so be it. Well, that's where it should have ended. But here you see a picture of another person, and this gentleman's name is Frederick Allison. Frederick Allison wrote a weekly weather column for his newspaper, the Halifax Evening Express. Somehow or other, he heard, I guess from friends in Europe or whatever, about this prediction that Saxby had made regarding the upcoming new moon. And rather than just question it, Allison, decided that he was going to make do and try to make a prediction of his own. He made the assumption that, maybe this might be something that will affect our area here in Atlantic Canada, in the Maritimes, Nova Scotia or Newfoundland or New Brunswick. And so the week before the projected new moon and the supposed storm, in his newspaper column, again appearing in the Halifax Evening Express, Allison made a prediction, again based solely on Saxby's forecast. His prediction, which was printed, here you go, and here you see it, in the Halifax Evening Express on October 1st, 1869, he said, "I believe that a heavy gale will be encountered here on Tuesday next, the 5th of October. That's the day of the new moon. Beginning perhaps on Monday night, possibly deferred to as late as this Tuesday night. But between these two periods, it seems inevitable. Roughly speaking, the warmer it may be on the 4th, the more violent will be the succeeding storm." Apart from the theory of the moon's attraction as applied to meteorology, which is disbelief by many, in other words, he's making this off-the-cuff remark that a lot of meteorologists didn't really believe that the moon had anything to do with weather or the prediction of forecasting. And he said this in this nicely worded statement here, which is disbelief by many. "The experience of any careful observer teaches him to look for a storm at next new moon." Well, again, he wrote this on October 1st. He's talking about October 4th and 5th. Now today, what is that? That's not much of a prediction. Every night when you look on television, they present to you the 7-day outlook. A couple of TV stations in the Northeast, I'm sure in the Boston market and Hartford or whatever, I'm sure that there's some stations that may even go as long as 10 days out. So making a prediction only 4 days out is no big deal today. But in 1869, yeah, that was still pretty much sticking your neck out, way out. And again, he's predicting this storm based upon the movement of the moon and based upon a prediction that was made by a gentleman across the Great Pond in the United Kingdom, which everybody was saying was like a bunch of foo-foo. But take a look at this. Little did anybody know on October 1st of 1869 that off of the southeast coastline of the United States, there was a hurricane. Yes, a hurricane that was apparently off the southeast coast, off the Carolina coast on October 1st, which gradually moved northeastward. Here it is on the 2nd, the 3rd. On October 4th, it was in the vicinity of Cape Cod, and it made landfall in Maine. Now, all around the storm track, there were violent winds, heavy rains, and when this system moved up into the Maritimes of Canada on the 6th and the 7th, it continued to bring violent winds, heavy rains, flooding rains, and caused a tremendous amount of destruction. Here's an artist's view of what was going on in parts of New England and Atlantic Canada. And the forecast seemingly was true. I mean, Saxby said that there was going to be a big storm. Allison even went so far to say it was going to hit Atlantic Canada right around this time. But if Frederick Allison, was hoping that he would become famous by making such a prediction, he didn't. Because to this very day, in Atlantic Canada, when you mention October 1869, everybody says the same thing. Oh, you're referring to the Saxby storm, the Saxby gale. Everybody remembered the prediction made not by Frederick Allison, but by Stephen Saxby about this potential big storm. And of course, due to the fact that it coincided with that very close new moon, that only aggravated the whole situation in terms of tidal flooding. Now, many, many, many years later, in fact, in the year 2002, I wrote an article for WeatherWise magazine. And by the way, if any of you have any interest in weather, be it as an amateur or maybe you're considering becoming a professional meteorologist, I would strongly urge you to get a subscription to WeatherWise magazine. Thousands of amateur and professional meteorologists read this. And I wrote a feature article for WeatherWise in October of 2002 pointing out that, and this happens sometimes, I had a computer program that did studies of the motions of the moon and the planets, and discovered that the moon, the motions of the moon, which can be cyclical, the new moon in October of 2002, pretty much was going to be in the same position, the same situation, not only just a moon, but a new moon, but also a moon that was going to be close to the Earth, perigee, crossing the equator, just like it did in 1869. So my comment was in this article, is it lunacy to think that we could have another Saxby gale recur in October of 2002? So this article came out, in the September 2002 edition of WeatherWise. I'm sure a lot of people were thinking the same thing. Is it possible? Would it happen? Could we have another major storm similar to Saxby storm? In fact, the interesting thing is that mariners always talked about the line storm, when the sun crossed the line being the equator. And there was always a big storm, usually within a few days of the vernal equinox somewhere in the world, a storm that might bring a lot of storm, or same thing in September, for the autumnal equinox. And this was not too soon, not too long after the autumnal equinox in 2002. So all of these factors coming together. Now, you just can't do a forecast like this based upon one single storm. And I mentioned this in my article. I said if it was just one storm, if it was just the Saxby storm, all right, there may have been more coincidence than anything else. But I did find other cases where the moon was unusually close to the Earth, crossing the equator, either at full or new moon. And what happened after that occurrence? Here is the weather forecast that was issued by the National Weather Service. In those days, it was not the National Weather Service, it was the U.S. Weather Bureau. March 22nd, 1967. We had a full moon at perigee, and we also had the full moon was over the equator on that particular day, and it was also a day or two after the vernal equinox. This was the forecast for that day, March 22nd, 1967. This was printed in the New York Times. Mostly cloudy, with a few snow flurries likely, and then clearing this evening or tonight. Okay, that was the forecast. And now here's what actually happened. 10 inches of snow surprised the city and clogged roads. High drifts, slush, bedeviled pedestrians, schools close early. A spring snowstorm surprised the metropolitan area. And when they asked the chief meteorologist at 30 Rockefeller Center, they're now out in eastern Long Island, the weather services, but back then they were in Midtown Manhattan at the RCA building. Anthony Tancredo, I love this quote from him. First of all, the story wrote that the storm had moved very much as the forecasters had predicted. Normally, a storm like this would give up little or no snow, one meteorologist said, like a man trying to explain to his wife why he hadn't phoned when he missed the train. But Anthony Tancredo, the meteorologist in charge, likened the Tuesday-Wednesday forecast to good surgery that does not turn out well. The operation was successful, but the patient died. There was a storm on the map, but for whatever reason, the meteorologist couldn't explain, suddenly got very strong, very fast, very quickly, and produced that unexpected snowfall in 1967. All right, well, that's one example. Let's try something else. Here was a storm that was referred to as the storm of the century. In March of 1993, we had a super storm. This storm occurred and brought snow, heavy snow, from Birmingham, Alabama, all the way up into New England. And you see this area here on this satellite loop. This was a line of severe weather, thunderstorms, tornadoes, tremendous storm. This all took place during a particular scenario where we had a full moon again, and the moon was near perigee, and once again was crossing over the equator, just like Saxby's gale and just like that storm in 1967. And this storm system, which was centered right about here when this photograph was taken by satellite, this storm turned out to be one of the most intense storms in the eastern United States in the 20th century. A storm system that made headlines. You could see here, paralyzing the East Coast, snow covering the South, 33 killed. This storm, as the subtitle mentioned, humbling the northeastern United States. So I pointed out in the WeatherWise article, now it may have been coincidence in 1869. Then again, it happened again in 1967, but three times, three significant storms, either a hurricane or a nor'easter or a storm that got much stronger, unpredictable strengthening. What's going on here? Now we were looking at this in October of 2002. That's what brought attention to the potential for a storm in that year. Well, here we are. This is in late September of 2002, and looky what we have. We have a hurricane, Hurricane Kyle. This is out in the Atlantic Ocean. Here you see Puerto Rico, the Dominican Republic, the Atlantic Ocean, of course, Caribbean Sea, I should say, surrounding this intensifying hurricane. And the mainland United States is off the picture, off to the upper left. This is in late September. Where is this storm going to go? Is it going to repeat what we saw with Saxby's gale in 1869, the hurricane that occurred then? Well, when you have a hurricane, climatologically speaking, this is what you would normally expect to see. Storms that are located out where Kyle was in the Caribbean either will move on a course continuing north and west into Florida and eventually into the Gulf of Mexico. A storm that might have been south of Puerto Rico may have taken a curved path across to south of Cuba and Haiti and into the Gulf of Mexico, or a storm might actually curve northwest, north, and then away from the coast to the north and east. So what was Kyle going to do in 2002? Again, with that moon approaching perigee, and again, crossing the equator, a new moon. This was the path of of Hurricane Kyle. I mean, you know, this is almost like the storm was drunk, uh, making a loop here and then kind of wobbling this way and wobbling that way, going northwest, and then actually curving south and west, and then moving along the immediate coastline of the Carolinas. I mean, what the heck is this? I have seen many a path or track of hurricanes and tropical systems. Rarely do you ever see something looking as crazy as this, looping around, loopy doopy like that. But again, all of this coinciding with that closeness of the moon. Now, did the new moon have anything to do with this? The closeness of the moon, the crossing over the equator? I don't know. It might have been just the unusual upper level winds that forced the storm to take this crazy path. But what I can tell you is this: it's still a very contentious issue as to why the storm did this. And again, right around the time when we had that very close moon. So we talked about the moon's situation. What about other celestial objects? How about, for example, the sun? The sun, of course, is the reason why we're all here. Without the sun, without its heat, without its energy, without its light, we wouldn't be here at all. The sun, a great ball of gas, 864,000 miles across, is the part we see normally. All gas from its surface to its center, gas clear into its entirely hot central region, 11,000 degrees on the surface, almost 30 million degrees at its center. Gas, nonetheless, all the way through. Gas so dense that the average weight of a small amount of it, a cubic centimeter of this, is heavier than the weight of an equal amount of water. And interestingly, the sun sometimes seems to go through cycles where, well, it seems to have lots of spots on its surface, its photosphere. And then there are other times when there are no spots at all. There is, in fact, a roughly 11-year cycle, which we call the sunspot cycle, where the sun seems to have a lot of spots, and then 5 or 6 years later, it has few spots, and then we go back another 5 or 6 years, and the sun gets spotty again. These spots are magnetic storms on the surface of the sun, and they appear dark only because they are several thousand degrees cooler than the photosphere, the actual surface of the sun. If it were possible to take a sunspot, lift it off the surface of the sun, and put it up in the sky, it would appear very dazzling, very bright indeed. But because of that difference of, a few thousand degrees in temperature, the sunspots appear dark compared to the rest of the sun's surface. And as I said, there are cycles, again, roughly 11 years or so. And notice, if you will, that sometimes when the sun is at maximum, there are higher amounts of sunspots. Other years, other sunspot maxima are not quite as strong. We had some very high-level sunspot activity in the 1950s, and again around the 1990s. But then ever since the 90s, there have been sunspot maxima which have been diminishing. In other words, at each sunspot maximum after, and we've been counting off the sunspot cycles since the late 1700s. This is, in 2003, this was sunspot cycle number 23. In 2013, cycle number 24. We are currently in sunspot cycle number 25. And as you can see, with each cycle, the numbers of spots at maximum appear to be declining. In fact, this particular astronomer who passed on a few years ago, John Eddy, he's an American astronomer. He studied sunspot records. Again, he died in 2009. He looked at the spot records and noticed that there was a mention of the lack or paucity of sunspots during the late 1600s and early 1700s, particularly noted by a couple of astronomers, Gustav Sporer and Edward Maunder. And in fact, he's even referred to as the Maunder minimum. But Eddy said, I don't believe this happened. I'm going to do some checking, some research myself to see if indeed there was a lack of sunspots during that nearly 75-year time frame. Well, again, Edward Maunder, you see here, who lived in the early part of the 20th century, the turn of the 20th century. He was one of the first to make mention of the fact that there was no sunspots, 1645 to 1715. And another astronomer, Gustav Sporer, in the mid to late 19th century, he was actually the first to mention that there was a lack of spots, and this is what got Maunder interested. And Sporer, incidentally, also said that there was a lack of spots in 1420 to 1570. During that interval of approximately 150 years, he said sunspots, recorded sunspots, were virtually non-existent. And you read that and you say, well, wait a minute, Mr. Sporer, how could you make a statement like that? How could you make a statement? 1420 to 1570 was before the invention of the telescope. Galileo was the first one to see sunspots with his telescope, but that was in 1610. So how could you say, Mr. Sporer, that there were no sunspots during that 150-year time frame if there was nothing that we could look at the sun to to prove that point out? Well, Sporer said the reason why there were no sunspots was his study of rings, tree rings. He was a dendrochronologist, and he pointed out that when there were dry years, when there was a lack of any moisture, that the rings were exceptionally thin, and that when there was a lot of rain, that there would be wider rings on trees. And he pointed out that apparently, supposedly, when there was a lack of sunspots, those years were unusually dry and also unusually cold. In fact, John Eddy pointed out that during the time of the so-called Maunder minimum, 1645 to 1715, that there was a lack of sunspots, and also we went through in the Northern Hemisphere a period called the Little Ice Age. And he said, well, perhaps that might have had something to do with the lack of sunspots. Yet another person that took interest in this, John Dalton, an English chemist, physicist, meteorologist in the early 19th century, who pointed out that there was a lack of spots, a paucity of spots between 1790 and 1830. And during that time frame, there was again another period of unusually cold weather in the Northern Hemisphere, especially in his homeland of the United Kingdom and in Great Britain. In fact, during that time frame, the Dalton minimum, it got so cold that people in Holland, for example, were able to walk on the ice in exceptionally cold conditions. And also, something else, something that to this very day we take note of. Every year at Christmas time, what is one of the most popular stories that is cycled on television or on radio? And that is the story of Ebenezer Scrooge, A Christmas Carol, written by Charles Dickens. Dickens wrote that story in the early 1800s. In the early 1800s, in England, it was almost a given that when you got around to Christmas, it was going to be cold and it was also going to be snowy. Now, today, if you go to Great Britain and you visit somebody, let's say in London around December 25th, there's a fair chance that you're not going to see any cold or snowy weather. More likely, it's going to be, well, probably temperatures well above freezing. And if you do get any precipitation, it'll probably be rain. But that wasn't the case in the early 1800s. During that time, it was cold. And Dalton, John Dalton, the English chemist and meteorologist, said the reason that was happening was the paucity or lack of sunspots, just like during the Maunder minimum in the late 1600s and early 1700s, and like the Sporer minimum that was occurring in the 14 and 1500s, all due to the lack of sunspots. So, does the lack of sunspots mean that when there aren't any sunspots, the air is going, the atmosphere, the northern hemisphere would get very cold? Here's a study written by some Russian scientists, Zarkova et al. This was not too long ago, in 2015, and their survey, looking back at sunspot cycles, here they charted a period of medieval warm temperatures during the 1400s, followed by the Maunder minimum and the Dalton minimum, the Little Ice Age. Then we went through a period in the 20th century where we had a lot of sunspots, and he refers to that as the modern maximum. But now he is talking about for solar cycle 26. We're in 25 now, but in 26, there's presumably is going to be a period when there's going to be a lack of sunspots, and that he is predicting another possible little ice age that is going to envelop the northern hemisphere around that time. Take a look at this diagram, and you can see, and I mentioned this earlier, how with each successive solar maximum that the number of sunspots kept getting lower and lower and lower, from 21 all the way to 24. 24, there were months when there was not a single sunspot visible on the disk of the sun. And again, if you do some extrapolation, then it points to an even lower sunspot minimum for this current cycle, cycle number 25, and perhaps even bottoming out by cycle 26 during the decade of the 2030s. That sounds like a very, very good formula and prediction, except for one little problem. We are in the midst of solar cycle 25, and I must tell you right now that we are seeing solar activity the likes of which we have not seen in about 30 or 40 years. The sun has been very active, producing not only numerous sunspots, but also in recent months, lots of big solar flares. We just had one a couple of days, a sunspot emerging into view on the sun's disk, an X1 solar flare. X flares are the strongest solar flares. And we didn't have this during cycle 21, 22, 23, 24. All of a sudden, the sun has woken up. And that pretty much puts a monkey wrench, or throws a monkey wrench into the sunspot theory about how we may be seeing global cooling in the coming years ahead. I don't think if there is indeed a connection between sunspots and colder temperatures, I tell you, it ain't happening, not in the foreseeable future, if the sun continues to be getting more and more active, with a sunspot maximum expected in 2025 or thereabouts. We did, as I said, mention see very few sunspots in previous spot cycles, but that's not happening this time around. We're seeing a lot more sunspot activity. I interviewed this gentleman. This gentleman's name is Gavin Schmidt. He's a climatologist. When I was working in television, he's the climate modeler and director of NASA's Goddard Institute for Space Studies in New York. And when we had that period when we had a lack of any sunspots, I did an interview with him, and I said, Professor Schmidt, does this mean that we're heading for global cooling? And Professor Schmidt said in a resounding manner, absolutely, positively not. The sun has very little to do with the climate, with our atmosphere. So I said, well, then how do you explain the Maunder minimum? How do you explain the Dalton minimum? How do you explain the lack of spots, presumably that occurred in the 1400s with the Sporer minimum? How do you explain all of that? And he said, the reason that we had little ice ages at the same time that we had the lack of any sunspots was due to volcanism, due to an unusual amount or an unusual number of eruptions, volcanic eruptions. And these eruptions, when they do occur and when they're big enough, I'm not talking about just regular volcanoes, but volcanoes that, big ones like Krakatoa, for example, that belch tremendous amounts of ash and dust into the upper stratosphere, 10 to 20 miles high into space. And they create an aerosol cloud which envelops much of the northern hemisphere. And the sun, when it shines down on this cloud, the cloud acts as a screen and causes the incidence of solar activity, solar energy, to diminish. In other words, we're not getting as much sunshine or not getting as much energy from the sun because the aerosol cloud, for a few years, blocks off or reflects that solar, that sunshine back out into space. And according to Dr. Schmidt, we had a lot of major volcanic eruptions during the time of the Little Ice Age in the 17th and 18th century and back in the early 19th century. That, he said, is the main cause of why we saw the amount of the temperatures falling in the northern hemisphere. It has nothing to do with sunspots, he said. It was all due to volcano activity. Here is the Tambora volcano in 1815, one of the largest. In fact, some say it even rivaled the Krakatoa explosion in 1883, putting up so much ash and dust that for a couple of years, the atmosphere above the northern hemisphere, it was just much, much colder than normal. In fact, some in New England referred to 1816 as the year without a summer. It snowed in parts of New England in every month of the year, even in July and August. And the reason was likely due to the tremendous aerosol cloud, which reflected back out into space, the amount of sun energy that we normally would have gotten without the cloud in place, that giant cloud acting as a screen and helping to lower the temperatures. That was probably one of the main reasons why Dickens wrote Christmas Carol under situations with cold and snowy temperatures around Christmas time. So now we looked at the sun, we looked at the moon. How about the planets? Can the planets have anything to do with our weather and climate? From my personal vantage point, I'd say that's a lot of hogwash. But there is one person who believes in this theory, and this theory, first of all, before I talk about him, you can see here are the planets, and they were, when the planets align, does that have anything to do with our weather? Back in 1982, there was an alignment that was called the Great Alignment of planets. It actually really wasn't an alignment. They weren't aligned as you see here, but over an arc of about 80 degrees, all the planets were set up in such a way. And there was a couple of guys who claimed that that would cause major problems here on the Earth. This book was published in 1974, and it was called The Jupiter Effect. It was written by John Gribben and Stephen Plageman, with a foreword by none other than Isaac Asimov, which gave the book a really big boost. And the claim was that this alignment that was coming in 1982 was going to cause earthquakes, floods, tremendous storms, all kinds of devastation on our planet. Well, those of you who were around in 1982 may remember that nothing of the sort took place. The two gentlemen, Plageman and Gribben, they probably made quite a bit of money, but their reputation was probably shot. But what do they care? They made all that money off of the book. But still, it got a lot of people worried, a lot of people concerned in the years leading up to 1982, and it caused a lot of copycat books that came out. Like, for example, this book called Earthquake, When Planets Align, 1982. And this was written by a gentleman named Doug Clark, who I guess wanted to get into the action as well. But again, nothing happened. I mean, planetary alignments don't really have anything to do with weather and with our climatology, does it? Well, maybe it does. This gentleman is a personal friend of mine. His name is Jim Witt, and I worked for him for a short time back in the 1990s. Jim is a meteorologist, and Jim likes to talk about weather to anybody who wants to, have a conversation about weather. There Jim is. And he puts out a calendar called the Long Range Weather Calendar. And if you buy his calendar, it comes out every year in the fall, and he predicts the weather based upon a variety of different things: the sun, the moon, and yes, he told me the position of the planets. And I said, Jim, how do you I can understand the sun with its heat and light. I can understand the moon with its closeness to the earth and its movement around the earth. But how can you even suggest that, let's say, the planet Saturn has anything to do with our weather? Saturn's like almost 1 billion miles away from the earth. But Jim tells me that this is his methodology, and here is where he learned it from. First of all, Jim used to teach at the Lakeland High School in northern Westchester County. In fact, back in the 1960s, there was a weather club, and it was headed up by Jim, who was the science teacher there. And they were actually able to get for the school all kinds of fancy weather equipment. In fact, there was a naval station down in Texas that was getting rid of their radar. They're just junking it, saying, we don't need this anymore. We're getting a brand new radar. Jim found out about it, contacted the Naval Air Station and said, could we have your radar? Can we have it? And the Naval Station said, yeah. He said, well, tell you what, we were so anxious to get rid of it, we'll ship it up to where you are, your school. They shipped it. They set it up. The kids, not, fancy electricians, the kids at the school were able to work on the radar, and they got it into working condition. That plus all the other weather instruments that they had at the school. This was a highfalutin club, and many of our major noteworthy meteorologists came out of this club, and they all came out of it thanks to the leadership of Jim Witt. This was in Weatherwise magazine again, a look back at the legacy of the club from 55 years ago. Here is Jim, and he's looking over a map that is being plotted by the young man that you see there in the picture is James Hack, who eventually became Dr. James Hack, director of the Hurricane Research Division at the Atlantic Oceanographic and Meteorology Laboratory for NOAA. And this is just one example of some of the many kids who were taught by Jim and went on to bigger and better things. So when I asked Jim about how he got into forecasting long-range forecasts, remember that story I told you about Harry Geiss and the Christmas snowstorm of 1966? Jim was sitting in his living room watching the forecasts that were being projected about this storm by Harry Geiss. And when the forecast came true, Jim wrote a letter and then made a phone call to Harry Geiss, and Harry invited Jim Witt down to CBS. And Jim said flat out, I have to know, how did you do it? How did you make this long range forecast? And Harry Geiss said, look, he said, this methodology is my very own. He said, but I heard about you and I heard about what you've been doing with your kids at Lakeland High School. So this is what I'm going to do just for you. I am going to give you not the whole solution, but parts of the solution. I'm going to give you some hints. I'm going to give you some clues. Then you work out your methodology and figure it out for yourself. And Jim did. Over a span of the next 20 years, Jim started working on making long-range weather predictions using, and apparently this is what Harry Geiss used, the sun, the planets, the moon, and beginning in 1986, Jim started to advertise these long-range forecasts on the radio. Jim has and still is a voice on WHUD radio in the Hudson Valley of New York. You can hear him on Saturday mornings giving his weather forecasts. And every year, starting in 1986, he started giving a forecast, I think in the early 80s. He'd tell the listeners, you write in and I'll send a self-addressed stamped envelope, and I'll send you my prediction as to what I'm expecting for the upcoming winter season, as to how much snow we're going to get and whatever. And the station got devastated. I mean, they would get tremendous amounts of mail. Finally, in 1986, the owner of WHUD said, here's what we would like to suggest. We'd like you to make a calendar. We'll make a calendar, and you could do a whole year's worth of long-range forecasts, and we'll sell the calendar, and we'll make a nice little bundle of money, the station, and you too, you'll get a good cut out of this. And Jim said, I have a better idea. He said, there are kids in this world who have been dealt a bad hand in life, kids who are suffering from various types of diseases and whatever. He said, I'm going to start a foundation called the Hope for Youth Foundation. And what I'd like to suggest is that the money that we raise from this calendar, every cent of it goes into the Hope for Youth Foundation. And then what we will do is that we will distribute this money to children's charities, St. Jude, for example, Ronald McDonald House, many, many charities, all dealing with helping out children. WHUD said, that sounds a wonderful idea. And ever since 1986, Jim has been selling this calendar, and it has become a very popular calendar, and it's even available up in New England. So you folks up in New England can get it. You see the website there for Hope for Youth Foundation, www.hfyf.org. Or you can even go Google Jim Witt weather calendar and find out more information online. Over the years, since 1986 up until the present, Jim has made, selling this calendar, single-handedly now, over $4 million. And while Jim and I have had arguments about forecasting the weather using the planets, and I said, Jim, I really cannot believe any of that, up until recently, actually. I said, I disagree with a lot of your methodology. I cannot disagree with what he has been doing with these long-range forecasts. And he claims, like the Farmer's Almanacs, both of them, that his accuracy is very, very good, 75 to 80%. In fact, in the back of his calendar, now Jim is getting up there in years. Jim is now 80, 85 years old. And he said, I may not be around too much longer. So he's made up forecasts and has them in the back of his calendar. These are important dates, he says, to watch in the future. Important dates to watch for big storms. Look at this. They go all the way out to the year 2028. Specific dates of times when you might expect a major cold front, a major hurricane, a nor'easter, or something. So, for the benefit of our viewing audience right now, I'm going to share with you his predictions. You can, if you have a pencil or a pad, you can write these dates down. Let's see what happens. He's forecasting major or significant storminess in this part of the country, the Northeast, on July the 6th, July 26th through 28th, and then in August, the 22nd through the 24th, in September, 14th to the 16th, October 6th through the 8th, December, now we're getting into wintertime season, 12th to the 14th, and December 17th to the 19th. Again, Jim claims, again, not 100% accuracy, who is 100%, but very, very good accuracy with predictions in terms of storminess and major events. And again, his calendar has become very popular. I would suppose that if it was inaccurate, I don't think people are buying the calendar just for the pretty pictures. They're buying it for some reason. And I haven't checked. I haven't done any scorekeeping on any of these predictions, but there they are for you to check to see whether or not anything unusual will happen storm-wise during those specific times. As I said, I didn't really think that the planets would have anything to do with our weather. But recently, going back now to a paper that was written by Dennis Kent of the Lamont Earth Observatory at Columbia University, a paper that was written back in May of 2018, Professor Kent wrote, Jupiter and Venus are such strong influences because of their size and proximity. Venus is the nearest planet to us and roughly similar in mass. Jupiter is much farther away, but is the solar system's largest planet. According to Professor Kent, there is a cycle every 405,000 years due to wobbles in our orbit caused by the gravitational pulls of these two planets. Seasonal differences here on Earth become more intense. Summers are hotter, winters are colder, dry times are drier, wet times are wetter. I read this and I said, well, I'm not going to be around in 405,000 years, but the very fact that a very competent, respected scientist is saying that planet and their movements around the sun may have indeed an effect on our climate, well, that's good enough for me. And I actually contacted Jim and said, you ought to read this paper, Jim. I think you're right, to a degree, that maybe the weather can be controlled in a small way by the planets. But again, a very contentious issue. I myself, as I said, was in the weather business on TV and radio for over 40 years. And I tell people that when I was on television that I had an accuracy. I wasn't going long range, but short-term forecasts, I said my forecasts were generally on the order of about 90% accurate. Yeah, sometimes something didn't work out the way I thought it would. Like, for example, I might tell somebody, or I might tell my television audience, we're going to have some light snow tonight. When you wake up tomorrow morning, there might be a light coating or dusting. And then I wake up the next morning and look out the window and it's snowing to beat the band and there's already 3 or 4 inches of snow on the ground. That's when I had what I refer to as a Gomer pile, because I would hear the voice of the late Jim Neighbors in the back of my head saying, surprise, surprise, surprise. No matter how technological and how accurate our machines are, our model guidance is that we base our forecasts on. Sometimes something falls through the cracks, and sometimes you end up with these situations where you get indeed a surprise. That's the way it is in weather. That's the way it can go sometimes. And it happens not just in weather, it can happen in other fields as well. Those of you in New England in particular, you probably recognize this gentleman. His name is Bill Buckner. Now, Bill Buckner, this guy belongs in the Hall of Fame. Or if he doesn't belong in the Hall of Fame, he comes just short of getting into the Baseball Hall of Fame. A tremendous hitter. He won, I think, several batting championships. A very good fielder. And also a gentleman of the first magnitude. As I said, In weather, it sometimes happens that you blow a forecast. I always say people never remember the forecast that I got right. They always seem to remember the forecast that I got wrong. In Bill's case, Bill Buckner's case, he was a fantastic baseball player. But what do people remember Bill Buckner for? They remember him for one thing: a ball that went through his legs in Game 6 of the 1986 World Series and allowed the New York Mets to come from behind, win that game, and eventually win the 1986 World Series championship. And they all blamed Bill Buckner for that ball going through the legs. They all blamed Bill Buckner for losing the World Series that year, and that was absolutely unfair. Unfair to Bill. And I say, and Bill passed away a few years ago, but I said if I ever had a chance to meet him, I would just come up to him, pat him on the back, and say, I know how you feel. Because what happened to Bill also happens to us in the weather industry. It is what we call the weatherman's lament. I leave all of you with this. Here is life's great December. Those in the main are our regrets. When we're right, no one remembers. When we're wrong, no one forgets. Well, I went a little over my 1 hour time limit, but I've enjoyed thoroughly talking to you about one of my favorite subjects, the weather. And I hope that all of you found it interesting. And again, I'll be back in October. We'll be talking about another special event, the eclipses. The eclipse of the sun coming in October, and the big eclipse is coming in April. Those of you, you probably aren't aware of the date just yet, but it is a date that all of you will come to know, I guarantee you, by early next year. Monday, April 8th, 2024, a fabulous total eclipse, which will be visible in parts of upstate New York and New England. And I hope every one of you get a chance to see it, and we'll talk more about that in detail in October. But again, I thank the library for inviting me back to talk about this event of long-range forecasting. And if you have any questions, I'll be very happy to try to answer them for you right now. All you need to do is unmute yourself and shout out your question, and I'll try to answer them for you. And if you don't have any questions, I guess I'll just say thank you very much and have a good night.
Yeah, thank you, Joe. Just in case anyone wants to ask a question to Joe and you're a bit camera shy, feel free to shoot the library an email, and then I can shoot that to Joe, and then we can handle it that way. I know that some of our patrons are a bit more shy when it comes to talking on Zoom. But I just want to thank you, Joe. It was a very interesting program. I did not expect it to end with Bill Buckner, but I was pleasantly surprised.
I was at
Yankee fan.
I feel so. Let me tell you, I was at that game. I was at Shea Stadium. I was at that game that night. I'm a big Met fan. I was happy. I was thrilled. I was so. And the thing that I regret, this is the one thing that I regret, and unfortunately, I'll never have a chance to make up for it. In front of me, sitting in front of me during that game, there was a young lady, and she was wearing a Red Sox cap. And I remember when the Red Sox scored and went ahead of the Mets 5-3, and when the Mets were down to their final out, and this young lady, I was 30 years old. This girl looked like she was in her 20s, and she's like clapping. She's so happy. The Red Sox are finally going to win a championship. Oh, I'm so happy. She was just like, she couldn't wait for the final out. And of course, we all remember, I know Red Sox fans remember what happened and that amazing comeback victory. And when the Mets scored the winning run on the ball going through Buckner's legs, I leaned over to this young lady and I screamed into her ear, "Just remember, young lady, don't bet on the Red Sox." I think she was about to cry. She got she left very quickly. And all these years later, I think about what I did, and I said, "You idiot, you moron, this poor girl. How could you make that girl feel?"
Right.
And I felt so happy for her when the Red Sox finally won in 2004 and again in 2007. But I felt so bad, and I said, if I only knew that girl's name or her Facebook address or something like that, I would try to
Right.
contact her and just apologize for doing that. That was a little out of hand, but that's what happened when I'm going through the legs. I mean, there were people who would. I actually was hugging people I didn't even know.
Yeah.
People were jumping up and down, each other, whatever. But and Bill Buckner really does belong, and I hope he does someday get into the Hall of Fame. He didn't need to have a wonderful career tarnished like that for a stupid little error that
Right.
went his legs in 1986. Well, anyway, enough with baseball. On we go to eclipses, and we'll be back in October, and we'll talk about that event. I thank all of you for coming tonight to listen about long range weather from the sun, the moon, and the planets.
Thank you so much, Joe.
Have a good evening, everybody, and happy summer.